with multiplying and dividing. Okay, so last that we finished was adding and subtracting scientific notation. So this week, today, we'll be multiplying and dividing scientific notation. And both will be on your test prep on Wednesday. So let's get into it. Multiplying with scientific notation. To multiply values in scientific notation, you want to rearrange the multiplication. So rearrange the multiplication problem and apply the properties of exponents. So rearranging it, meaning you're going to put all of your constants together. So I'm going to multiply 4 and 5/10 times 2. And I'm going to multiply 10 and 10 to the 5th power times 10 to the 3rd power. Then you're going to apply the same rules that you will when you multiply. Because parentheses, these parentheses around each of these mean to multiply. Okay, so we're just going to apply the rules of multiplication to both of these. Okay, so when you multiply 4 and 5/10 times 2, 5 times 2 is 10, carry a 1. 4 times 2 is 8, plus 1 is 9. You have one decimal place here. So you're going to move it one decimal place, which is 9.0, times. When you have the same base, you multiply by adding the exponents. Keep the base, add the exponents. So your final answer is 9.0 times 10 to the 8th power. So let's look at numbers 1, 2, and 3. It says find each product and record your solutions in scientific notation. The word product means to multiply. And it says record your solution. Solution means the answer in scientific notation. Remember, scientific notation is a number that's greater than or equal to 1 but less than 10 times a power of 10. That's what scientific notation is. So we want to make sure that we write our final answer as a number between 1 and 10 times the power of 10. Okay, for our first problem, we want to bring our numbers together. So 1 and 5/10 times 5 and multiply our exponents together. So now multiply 1 and 5/10 times 5. 5 times 5 is 25. Carry a 2. 1 times 5 is 5 plus 2 is 7. You have one decimal place. So that's 7 and 5/10 times 10 to the, here we have the same base, so we add the exponents. A -5 plus a -3 is a -8 power. Number 2. Number 2, our numbers are 3 times 7 and 2/10 times our bases with the exponents of 4 and 2. So you multiply 7 and 2/10 times 3. 3 times 2 is 6. 7 times 3 is 21. You have one decimal place. So that's 21 and 6/10 times, keep the base, add the exponents. It says 21 and 6/10 times 10 to the 6th power. But remember, our final answer must be in scientific notation. So remember, in scientific notation, it's a number between 1 and 10 times the power of 10. So I have to move the decimal one time to the left. Remember, when I make the number smaller, I have to make the exponent larger by however many times I move the decimal. So my final answer is 2 and 1600 times 10 to the 7th power. Number 3. Number 3, my numbers that are being multiplied is 2 and 2/10 times 8 and 5/10. And we multiply 10 to the -2 times 10 to the positive 6. So we can multiply our decimals here out to the side. It doesn't matter which order you put it in. I could have put 2 and 2/10 at the top. It doesn't matter when you're multiplying. So I have 5 times 2 is 10. Carry my 1. 8 times 2, 16 plus 1, 17. 2 times 5 is 10. Because I multiplied it with a 2, I'm putting it under that place value. Carry your 1. So you have 8 times 2 is 16 plus 1 is 17. Let's add it up. We have 0, 7, 8, 1. 2. We have 2 decimal places. A decimal place here, decimal place here. It says 18 and 70 hundredths. And then I'm multiplying it by 10. I'm adding the exponents because they have the same base. That gives me 18 and 70 hundredths times 10 to the 4th power. Because unlike signs, you subtract and take the sign of the larger absolute value. But because this number 18 is not in scientific notation, I have to move the decimal one place to the left. So put it in scientific notation, make that number smaller, and make the exponent larger by adding 1. So my final answer is 8 and that's tenths is the 8, 7 is the 100, 0 is the thousands. So 1 and 870 thousandths times 10 to the 5th power. Let's move on to dividing. Dividing with scientific notation is similar to multiplying. The only difference is you're dividing and you're still rearranging the division problem and applying the properties of exponents. Okay, let's look at our first example. We have 8 times 10 to the 6 and 4 times 10 cubed. A fraction bar means to divide. So we want to treat both of these as division problems. So we have 8 divided by 4 and then 10 to the 6th power divided by 10 to the 3rd power. You can also write those as 2 fractions. So you can write that also as 8 divided by 4 times 10 to the 6th divided by 10 cubed. Okay, both of them are correct. So when I divide 4 into 8, it goes 2 times. When I'm dividing with the same base, I subtract the exponents. So your final answer is 2 times 10 to the 3rd power. Number 4. Number 4, same thing. We want to divide 9 divided by 3 times 10 to the 9 minus 7. Because it divided with the same base, you're going to subtract the exponents. Okay? But we can write this so that I can make sure that you guys don't see us skipping any steps. That's 10 to the 9th divided by 10 to the 7th. Okay? So 3 goes into 9 3 times 10 to the 9 minus 7. So your final answer is 3 times 10 squared. Number 5. We want to divide 2 and 1/10 divided into 9 and 45 hundredths. So we have to move the decimal 1 time to the right in the dividend to make it a whole number, and we move it 1 time to the right in the divisor, which makes 21 divided into 94 and 5/10. You want to bring up your decimal and divide regular. So 21 goes into 94 4 times. 4 times 21 is 84. You subtract, you get 10. Bring down your 5. 21 goes in 105 5 times. 5 times 21 is 105. Subtract. You don't get a remainder. So now I have 4 and 5 tenths times 10 to the 7 minus 2 because we're dividing. So 4 and 5 tenths times 10 to the 5th power is your answer. Number 6. Number 6, we're going to divide 5 divided by 10. Or we can actually write that as a fraction so you all can see how easy it is to simplify this one. Times 10 to the negative 5 minus a negative 2. Because when you divide it with the same base, you subtract the exponents. 5 divided by 10 is 1/2 times 10 to the negative 5 plus 2. A negative 5 plus 2 is a negative 3. So this is 1/2. Another way of writing 1/2 is 0.5 times 10 to the negative 3. Well, of course, 0.5 is not written in scientific notation. So I need to move the decimal one place to the left. One place to the right. If I move the decimal one place to the right, I make this number larger. If I make this number larger, I got to take one away to make this number smaller. So this gives me 5 times 10 to the negative 4 power, which is your final answer. All right, I hope you don't have any questions about the first page. Let's look at the second page. In number 7 through 12 is what we're working on now. 7 through 10, we're going to find the product or the quotient and record our solutions in scientific notation and standard notation. Okay. Here, I'm going to put this first number in scientific notation because I really don't want to multiply that long number. So we're going to move the decimal 1, 2, 3, 4, 5 times. So 1 and 2 tenths times 10 to the negative 5 because we started and our number was less than 1. And we're going to multiply that times 6 times 10 to the negative 2. Now this is written in a smaller form, so I'm going to now multiply 1 and 2 tenths times 6. 6 times 2 is 12, carry a 1. 6 times 1 is 6, plus 1 is 7. So that's 7 and 2 tenths times 10 to the negative 5 plus a negative 2. So in scientific notation, it's 7 and 2 tenths times 10 to the negative 7. And in standard form, that negative tells me I have to move the decimal 7 times to the left. So I have a total of 6 zeros. 1, 2, 3, 4, 5, 6, and then 7, 2. Number 8, we're going to multiply this by putting 4 thousandths in scientific notation, moving the decimal 1, 2, 3 times to the right. So this is 4 times 10 to the negative 3, multiplied by 7 and 3 tenths times 10 to the negative 1. Now I'm going to multiply 7 and 3 tenths times 4. This is 12, carry a 1. 28, 29. Have one decimal place. It says 29 and 2 tenths times 10 to the same base. Add the exponents. So it gives me 29 and 2 tenths times 10 to the negative 4. Remember to put it in scientific notation. It has to be a number between 1 and 10. So if I make this number smaller by 1, I make this number larger by 1. So this gives me 2 and 92 hundredths times 10 to the negative 3 power. In standard form, I need to move my decimal 3 times to the left, which means I'll have to have 2 zeros in front of the 2 as my final answer. Number 9. Number 9, I'm going to write the denominator in scientific notation. So I'm going to move this 1, 2, 3, 4, 5. So that's 3 times 10 to the negative 5. My numerator is 6 times 10 to the negative 3. So now I want to divide 6 divided by 3 times 10 to the negative 6 divided by, 10 to the negative 3. 10 to the negative 3 divided by 10 to the negative 5. 3 goes into 6 2 times. And here I have the same base, so I subtract the exponents. A negative in front of negative, make this a positive. So it's 2 times 10 to the negative 3 plus 5. Unlike signs you subtract, take the sign of the larger absolute value. So in scientific notation, it's 2 times 10 squared. In standard form, your exponent is positive, so I move the decimal 2 times to the right, which means I add 2 zeros, which is 100. And we know that 10 squared is 10 times 10, which equals 100. So multiplying 2 times 100 gives us 200. Number 10. I'm going to write my numerator in scientific notation by moving a decimal 1, 2, 3, 4 times. Because the number was greater than 1, the exponent is positive. I'm going to divide that by 1 and 2 tenths times 10 to the negative 1. So divide 1 and 2 tenths into 9 and 6 tenths. You move the decimal to make this a whole number. Move it over 1 time each. So 12 divided into 96. 12 times 8 is 96. So 12 times 8 is 96. When you subtract, you don't have a remainder. So that's 8 times 10 to the 4 minus a negative 1. So in scientific notation, a negative in front of a negative, make that a positive. So your final answer is 8 times 10 to the positive 5. In standard form, you'll move the decimal 5 times to the right, which means you need to add 5 zeros. 1, 2, 3, 4, 5. Between every third number, counting from the back, you'll put a comma. So your answer is 800,000. Number 11. Apply your knowledge of operation with scientific notation to answer numbers 11 and 12. Number 11. A top NBA player can earn about 2 and 5/10 times $7 per year. If John earns $40,000 per year at his starting job out of college, how many times greater is the NBA's player's salary? So this word, how many times greater, means we should be dividing to get the answer, because it's how many times greater. And they also say that they're allocating dollars each year. So this each year is also an indicator of how we need to solve this. Okay. So first thing we're going to do is put 40,000 in scientific notation. So that's 4.0 times 10 to the 1, 2, 3, fourth power. All right, we have 2 and 5/10 times 10 to the 7 power divided by 4 times 10 to the 4th power. Here we want to divide 4 into 2 and 5/10. So 4 goes into 2, it doesn't. Bring up your decimal. 4 goes into 25 6 times. 6 times 4 is 24. Subtract, you get 1. Add a 0. Bring it down. 4 goes into 10 2 times. 2 times 4 is 8. You subtract, you get 2. Add one more 0. 4 goes into 20 5 times. No remainder. So my decimal is 625 thousandths times 10 to the 7 minus 4. Because we kept the base, subtract the exponents. So this gives me 625 thousandths times 10 to the 3rd power. And this is not in scientific notation until we make this number larger by 1 and make this smaller by 1. So in scientific notation, it's 625 hundredths, 6 and 25 hundredths times 10 squared. In standard form, you move the decimal 2 times to the right. So that's 625 times greater. And the time greater goes for both answers, the scientific and standard. Number 2. If Kelly's heart beats on an average of 1 times 10 squared times per minute, by how many times does Kelly's heart beat in a year? If 1 year equals 525,600 minutes. So here we're multiplying. I'm going to first change this number into scientific notation. Because we have an average of a beat per minute, and we're trying to find how many beats in a year, this tells us to multiply. So first we're going to change 525,600 to scientific notation by moving our decimal 1, 2, 3, 4, 5 times to the right. So it gives me 5.256, so 5 and 256 thousandths times 10 to the 5th power. And I'm multiplying that by 1 times 10 squared, which is pretty easy because I'm multiplying 1 times 5 and 256 thousandths times 1, and I'm multiplying 10 to the 5th times 10 squared. Now I know that any number multiplied by 1 will give me that number, so that doesn't change. And when I'm multiplying with the same base, I add the exponents. So in scientific notation, it's 5 and 256 thousandths times 10 to the 7th power. And in standard form, I'm going to move my decimal 7 times to the right, which means I have to add 4 more zeros. And you just go ahead and put a comma between every third number. So your answer is 52,560,000 beats. I hope you understood and enjoyed today's lesson. This will be on your assessment on Wednesday. Please complete the summarize today's lesson, and you can start your homework, which is due tomorrow. Your homework due date is March 26, 2024, which is on a Tuesday. You must do all of the problems and show your work. You only have 8 problems. Most of it you should be able to get done in class. You will have another Delta Math this week with multiplying, dividing, and scientific notation. I will assign it today in case you finish your homework early. Let's make it a great day. Let me know if you have any questions.